Hey guys, and welcome to a new video. In this video here, we're going to talk about the new fast segment anything model. So this is basically just a fast version of the segment anything model from Meta AI. This is actually like a significant increase in the inference speed, as we're going to see in just a second. So first of all, we're going to open up in Google Colab. We're going to see how we can use it in a Google Colab notebook. Then we're going to see how we can set it up in our own environment on our own local machine. So we can use this segment anything model, run it live as well. We're going to test it out, set it up on our own environment, and then see how we can do inference, segment out anything in an image on our own local machine in a custom Python script. So let's now jump into the GitHub repository. We're just basically going to go through it. First of all, we're going to take a look at the model, also the inference speed compared to the segment anything model. So like the original SAM model from Meta AI. Here we can basically see that we have their GitHub repository. It was released a couple of days ago. It is actually like a significant upgrade or like increase in the inference speed. We can see it's up to like 50 times faster compared to the original SAM model from Meta AI. This is the new FastSAM. So this is actually like really cool. We can now go in and do like real time inference with this fast segment anything model. We can actually do segmentation on the live video stream or with a live webcam. So we can have a webcam in our own Python script, move it around and so on. We're going to create another video for that, where we're basically going to take a video or like a webcam. We're going to have a live webcam stream running this fast segment anything model on that webcam. So that's going to be a really awesome video. In this video here, we're just going to see how we can set it up, use it in Google Colab notebook for a single image just to do inference, and then also how we can do it in our own custom Python script if we want to run it through a video or something like that. Here we can see that we basically just take an input image. We can either throw it like through the original SAM model or the FastSAM model. It only takes like around 40 milliseconds per image with the FastSAM, and for the standard SAM from Meta AI, it takes over like 2000 milliseconds. So that's over 2 seconds to do inference. Of course, there's always a trade-off between like accuracy, performance, and also the inference speed. So the accuracy and performance is not as good with the FastSAM model compared to the original SAM model, but we still get some pretty good results. And now we can even like run it in real time. We get up to 50x speed increase when we're doing inference. So that is really cool. We only go down a bit of in performance. It doesn't really like matter that much if we're just running like live segmentation, or if you want to generate some segmentation mask for our object detectors and so on. So this is actually like based on the YOLO V8 model. So that is also like really good and really fast of actually like detecting objects and also running real time. So it is based on a convolutional backbone. So this FastSAM model, it is basically the YOLO V8 model together with segmenting out anything in the image. So here we can see that we can actually have this like real time, and now we're able to perform or like to achieve real time inference with this FastSAM model, where if we compare it to the original SAM model, which is based on the visual transformers, it is not like anywhere near able to run in real time. Here we can see the model architecture. So it's based on a convolutional neural network backbone. It has a future pyramid network here. It has the detection branch, and it also has these mask branch here to actually like do the segmentation. We can see we get some pretty nice results. The good thing about this segment anything model here as well, the FastSAM, is that we have this text encoder with the clip, and we also have an image encoder. So we can basically throw in different things. So we can throw in like a point prompt, box prompt, and also a text prompt. So if we want to detect or like segment out a specific object in our scene, we can basically just tell it to segment out the black dot here in the image. We can have like a box prompt. If we're doing detections with a YOLO model, for example, we can then throw that bounding box into the fast segment anything model, and then we can segment out the objects within that bounding box region. We can also just take a single point in the image, and then it will try to like figure out what is this object act like for this specific point, and then try to segment out that whole object in the image, as we can see here. So that is a bit overview over. So that's a quick overview over this model here. Now let's go into the Google Colab notebook, see how we can set it up, and then we're going to see how we can install it on our own local machine. So here we can see that we have this Google Colab notebook. We can change the runtime to GPU, so we can actually like use the GPU to increase the inference speed even more. So let's just run the blocks of code. So first of all, we need to just clone the GitHub repository that we just saw inside of GitHub. Then we also need to get the FastSAM model. So this is the FastSAM.pt. So we have the PyTorch models. We can actually like optimize it even more so we can get even faster inference speed if we convert it and optimize it to a framework like TensorRT. I even think that they show that on the GitHub repository. But then we can actually like run inference with like around 15 to 20 milliseconds per image. And it is actually like a very large improvement in inference speed, also just compared to the PyTorch model. So I think they're benchmarking it on a 3090 graphic card from NVIDIA. I'm using a 4090 on my computer, so we might see some better results later on, especially when we're going to run in real time on a live webcam. So now we're going to pip install the requirements from the GitHub repository and also this clip model for our text encoding. So those are the only things that we actually need to install. We're going to see how we can install it in our own content environment in just a second. But right now it should just take a couple of seconds to set up. We can also just run this. So it's basically just downloading an image example here from GitHub. So now we can see we have downloaded this image. Should be able to go over here and see it inside of our folder. So we have our images, and then we have this dog image that we're going to pass through our model and try to do segmentation of anything that is going on within this image. We're going to see the accuracy. We're also going to see how fast it actually runs. But this is just for a single example. We won't get really good, we won't get as good accuracy as the segment anything model from Meta AI, but it is also like significantly larger and takes up more time. And in most cases, we don't really need that good accuracy. We can see we have this FastSAM. This is basically just all the files from the GitHub repository. So now we can import our matplotlib so we can visualize the results and also OpenCV. Then we're going to open up or like read in the image with OpenCV from the directory. And then we're just going to convert it from BGR to RGB column format because that is the color format that this model takes in. First of all, we're going to get the width and the height of our original image. Then we basically just plot our image and show our image so we can see what are we actually going to feed through the model. So this is the input to the model. Then we want to segment out anything with the FastSAM model. So now we can use the inference Python script from the FastSAM GitHub repository that we have cloned. We need to specify the model path here. So we can see that we have this FastSAM.pt, and then we also need to specify the image path to the dog.jpg and also the image size. So we have 1024 here. So still a relatively large image, but we can actually run fairly fast inference. So let's run this now. It might take some time because first of all, we need to run the Python file here. It needs to import different kind of like modules, load the model and so on before it actually like does the inference. But we are going to see the inference speed when it has actually like done the forward pass of the image. After that, we're just going to like read in the image from our output directory, going to convert it from PGR to RGB so we can visualize it with matplotlib, and then we're just going to like do an im show with matplotlib. So it should just take a second or two here. We're going to see the time. So here we can see we have 124 milliseconds inference. So this is not as good GPU here in Google Colab, but it's still significantly faster compared to the SAM model. And when I'm going to run it locally, we're going to get way faster inference speed as well. We can also see it takes some time to do the pre-processing of the image and also the post-processing. But this is basically what's going on. We're detecting 35 objects within that image. Here we can just run it. So here we can see the results. It actually like does a pretty good job. We can see some of the boundaries, they're not segmented like perfectly, but that is what we can expect from this model when we want to act like optimize it for speed and so on. So it's always a trade-off between speed and accuracy. But again, we segment out like pretty much like all of the objects here, like the legs, the feet, the dog, like here, the bowl. We also have like a chair here in the background, the floor, the wall. So those are actually like some pretty nice segmentations just from this example image. So let's now go back here again to the GitHub repository and open up an anaconda prompt. And let's now go in and install it in our own local environment so we can see how fast it runs on my 4090 GPU, and also just to see how we can use it in our own Python script, because we might want to do it on a video, and then later on we also might want to do it on a live webcam. So we can basically just move a camera around, segment out anything that the webcam sees. So first of all, we just need to GitHub like clone our repository. So let's do that. You have the command prompt, just going to copy paste it, cloning into FastSAM. After that, we're going to create a new anaconda environment, and then we're going to use Python 3.9. So we're just going to create that. After that is created, we can go in and activate that environment. So here we basically just all that I had though that environment existing. So first of all, we just need to delete it, overriding it. So we're basically just basically just installing it here from scratch so you guys can see how to install it and set it up, but it is basically like straightforward. So now we're going to activate the FastSAM environment. We need to cd into our FastSAM to install the packages, and then we have our requirements text file where we have all the modules and the requirements that we need. So we can just go and directly pip install that. And the last thing that we need to do is actually just install our clip module here. So this might just take a couple of seconds or like a minute or two before it is actually done installing these different modules. So we can see that it installs like OpenCV, Python, SciPy, Torch, and so on. We might actually need to go in and verify that we're using a CUDA version of PyTorch. So here I can see that it just downloads the original PyTorch without CUDA support. So let's now go inside PyTorch here and actually like install the CUDA version. So here we just go inside the PyTorch website, pip install Torch Vision, CUDA 11.7. So I'm just going to copy that, go inside my environment. So right now it's still installing all the other modules, but after that we need to pip uninstall our Torch and also Torch Vision, and then we can go in and install it with CUDA support. So it doesn't really do that as default, and if you don't do it, it will only be able to run in the CPU. If you have an NVIDIA GPU, you will need to do this, or else it won't be able to detect it and use the GPU for inference. So this should be done in just a second. Let's go back to the GitHub repository as well. There we go, we're now done. Let's go in and act like, first of all, we need to pip uninstall it. So let's do that. So pip uninstall Torch, and we also need to pip uninstall Torch Vision. So let's start with doing that. Yes, and yes. And now we can go in and pip install it with CUDA support. After we're done, then we can go in and install our clip for our text encoding to our model. So this is basically what it's using for encoding the text that we throw into it with a text prompt and so on. So we can segment out specific objects in the scene. And I'm going to show you how to do that in our custom Python script as well. So this might just take a second or two. It has to download this 2.3 gigabytes. And then we need to pip install clip. After that, we also need to go in and install the download the model weights. So they have two different kind of like models. They have a default ones, and then they also have like a faster one or like a smaller model. So this is based on the YOLO V8 small model, and this is based on the YOLO V8 X model. So this is actually like significantly better than the other one here, but it really depends on your hardware, the performance that you need, and also the inference speed. So this will also be significantly faster than the other one. Again, it's a trade-off between accuracy and speed, but I've downloaded both of them to my computer, and then you basically just need to copy paste those into your directory that we're going to use. So let's go back here again. Now we have everything installed. We can now open up our Visual Studio Code. So we are now opening up Visual Studio Code. I've opened up the FastSAM repository that we cloned from their GitHub. We can now see that I've copy pasted these two FastSAM models. So we have the small model, and then we also have the X model as well. So the larger or the default model. Then we have our inference Python script, but we can also go down and use this segpredict.py. So first of all, here we import the FastSAM model from FastSAM, and we also need to import Torch. Then we can set up an instance of our model. We need to specify the path to our FastSAM model. So here, let's just start with the X model or the default one. And then we also need to specify the directory where we want to have our image for inference. We can then set up the device here, the CUDA device that we're going to use. So if CUDA is available, we're going to use the GPU. If we have MPS available, if you're on a Mac, with MPS available, it's going to use that, or else if you don't have all of those things, it will just use the CPU as default. After that, we can then do a forward pass of our model. So we have our model, we pass in the image path, so we don't need to like load an image first of all, we just need to pass in the image path. Later on, I'm going to show you how we can run this on a live video stream, but in this video here, we're basically just going to show how to set it up and load a single image. So make sure to hit the subscribe button and bell notification under the video so you get a notification when I upload that video, so we can see how we can run real-time inference with this FastSAM model on a live webcam. So then we do a forward pass, we specify the device, retina mask, the image size, also the confidence score, and our intersection over union threshold. Then we can also set up a FastSAM prompt if we want to prompt it with something. It could either be like a bounding box prompt, a text prompt, or a point prompt. So that is how we can set that up. They have basically just have an example here. We can try to test that out. But first of all, here we're just going to try to segment out anything. We should be able to just run it directly. We create an instance of our model. We have the correct directory here for our doc. So let's just run it and see the results. First of all, we need to set it up. So no module name clip. So let's just make sure that we actually like installed that. So we did actually like install clip. Let me just make sure that we're inside the correct environment. There we go. Run, conda, activate. Now we should be able to run it. There we go. We got the inference results. So here we can see that it took around like 50 milliseconds to run inference. So this is kind of like similar to what they had in the GitHub repository. Still very fast. This is around like 20 frames per second when we have 55 milliseconds. It only takes like 5 milliseconds to do the pre-processing, also the post-processing. So still fairly good. We detected around like 21 objects in this example. Let's go inside the output so we can see the doc. So this is actually like the results that we got. Let me just make sure that we actually had that. So we should actually be able to segment out like anything. Let me just go back here and see. So here, everything prompt, prompt process. Oops, we actually just need to delete this one here. So here we just have like single point. So we were actually like using the point prompt in this example here. So that is how you can use that. So that was the point prompt. Let's run it again. And now we should actually like go in and just segment out anything. So let's run it again. We'll take a second or two. There we go. We got the inference result around 60 milliseconds. Now we're detecting 21 objects. Let's just go up inside the docs. So yeah, now we can see that we're basically segmenting out anything. We don't really get the exact same results as with the standard like segment anything model from Meta. We segment out the docs here. They look pretty good. We also have the sand. The sky here is not really segmented out that good. We can see like the wooden stick here that they have in the mouth. It also looks pretty good. The leg here is not really that good. So we can see we don't really get the exact same accuracy, but this is still like fairly good. Again, this is with the large model. We can also try with the smaller model. So let's go in and run that. So that is the small model. Then we can also see the inference speed. So let's just pass the exact same image through that. After we've done that, let's just try with the cat example that they have as well. So now we can see that this was actually like significantly faster. So now we're running like 30 milliseconds here for inference. So that's actually like 30 frames per second plus. Let's going to see the results. We have the doc. Now it doesn't segment out the docs individually. It doesn't segment out like the sand here. It doesn't segment out like the sky. So these results here, they're not really good. Like they're probably only good for these points here. Let's try to do it with the point again. So the point prompt. So let's do that. So we just specify the exact same point for the right dog. Let's run it and see the results, and then we can test out the cat example. So here again, 33 milliseconds. See the dogs. So here we see that we specified a point around here, but now it actually like segments out both dogs compared to like the large model or like the default model, where it could actually like segment out the individual dogs, which was actually like pretty nice. So I don't really think that the results for the small model is that good. Of course, it runs faster, but I don't really feel like the results are that good with the small model compared to the large model. So let's just go with the large model and try it out with the cat example. So that's just the cat. And let's run it again. It will take a bit longer now, but then we should be able to see the results. Here we go, 60 milliseconds. Let's see the cat example. So here we actually got a pretty good one. So this is still the point example that we see. We get some really nice boundaries or like shapes here around our boundaries of our cat. This looks pretty good. Let's try to just delete this point prompt. Run it again. Let's go and see cat. Pretty good annotations here, like pretty good segmentation. We can see that it actually like segments out the eyes here. Some pretty good segmentation for the table that the cat sits on. Also the background with the wall. We have some problems here with the ear, but still nice boundaries around like most of the objects in the scene. So I actually think that these results, they look fairly good. We can also go in and try with like, for example, like a text prompt. So let's go in and try that. So here we have an annotation with a text prompt, which is also like fairly nice. Now we should probably go up and specify the docs again. So let's use the doc example. And now we just want to throw in the text a photo of a dog, and then we want to segment out that. So first of all, here we can see that we actually need to like download another model here. So this is basically just for a clip model that we need to use for encoding our text that we can then feed into our fast segment anything model as well. There we go. We should be able to go up and see our dog example now. So yeah, there we go. Now we can see that it actually like segments out this dog. We could have maybe have specified it should segment out like the black dog. Let's just try that. A photo of a dog. So a black dog. Let's try to run it again and see if we get some different results. Just directly going to run it. Let's try to see if it actually like just segments out the right dog now. It should be done now. But yeah, we can see that now it actually like segments out the black dog here compared to the other one. So again, it is really nice that we can go in and do segmentations based on these annotations and also based on text prompts, because now you can go in and do auto labeling of your data set. If you're, for example, doing segmentation tasks for specific objects, you have a whole data set, you can basically just throw it in here, use the clip model to actually go in and encode your text. Use that together with the segment anything model. So instead of using the SAM model, you just use this fast segment anything. So you can also label your data set significantly faster. So this is a really cool model. I'm really excited to get to play with it and also play with it more in the future. We're going to try to run real-time inference on a webcam as well. So definitely make sure that you watch that video once that is out. So thank you guys for watching this video here. And again, remember to subscribe button and bell notification under the video. Also like this video here if you like the content and you want more in the future. Really excited for the future videos. These are some really cool models that we can use for a lot of different kind of like domains, tasks for object detection, object segmentation, and so on. So I hope to see you in one of the next videos, guys. Bye for now.